We talk about quality all the time, right? The quality of our food, the quality of the things we buy, even the quality of our lives. But have you ever stopped to think about the quality of the electricity that's, well, powering everything? Let's dive in, because it turns out that invisible energy hiding in our walls isn't always as perfect as we think. And that imperfection, it comes with a truly massive price tag. Just look at this number, $300 billion. According to studies, that's the estimated cost that businesses around the world lose every single year, all because of bad power. It's an absolutely staggering number for a problem most of us don't even realize is happening.
So what is this $300 billion problem really? In this explainer, we're going to unpack what power quality actually means, why it matters so much, and what's causing all this trouble in the first place.
It really is a simple question, but the answers get pretty complex. We expect the light to just turn on, right? But behind that simple flip of a switch is this incredibly complex system. And the quality of the power it delivers is this critical, invisible ingredient that decides whether our modern world runs smoothly or just grinds to a halt.
Okay, to really get this, let's just break it down into a simple comparison. What's really the difference between good power and bad power?
Let's try an analogy. Think about your car and the fuel you put in it. If you use clean, high-quality gas, your engine just purrs. It runs smoothly. But what if you put in dirty, contaminated fuel? The engine's going to sputter, it's going to malfunction, and it might even fail completely. Well, good power is like that clean fuel for all our electronics. And bad power, that's the dirty stuff.
And that really gets to the heart of it. Every single piece of electrical gear we have, from a giant industrial motor to the charger for your phone, is designed to run on a very specific type of electricity. It's expecting this smooth, clean, predictable wave of energy called a sine wave. The moment it gets anything else, it's just like that car trying to run on bad fuel. Problems are going to happen.
So here's the more official definition. Power quality is basically any problem with the voltage, current, or frequency that causes our stuff to fail or just act weird. That's it. Any little deviation from that perfect, clean power is, by definition, a power quality problem. So how do these little deviations add up to billions of dollars? Why does a tiny flaw in an electrical wave cause so much financial damage? Well, it hits pretty much every industry you can think of. For a manufacturer, a tiny power glitch can shut down a whole assembly line. That means hours of lost time and huge amounts of money wasted. For data centers that are crunching massive amounts of information, even a millisecond of bad power can be a total disaster. Retailers can lose thousands if their freezers fail. And for critical places like hospitals, the stakes get so much higher. Let's just stick with data centers for a second. This figure is it's wild. Some studies show that a big data center can lose over $8,000 for every single minute it's offline. And one of the main reasons for that downtime? You guessed it, poor power quality.
And like I said, this isn't always about money. In a hospital, you've got life-saving equipment that absolutely depends on a perfectly stable power supply. As the source material points out, in these critical situations, a power quality issue isn't just some inconvenience. It could literally mean the difference between life and death.
So this brings up a really important question. If this power is so crucial, who's actually responsible for keeping it clean? Is it the utility company that delivers it to our door, or is it us, the customers who are using it? The answer, it turns out, isn't always so clear. It often leads to what people in the industry call the voltage blame game, this back and forth between the utility and the customer. Here's a key thing to understand. Most of the time, when experts are talking about power quality, what they're really talking about is voltage quality. And that's because the power utility, they can only control the voltage they deliver to your building. They have no control over what you decide to plug into your outlets.
So here's how it breaks down. The power utility is responsible for the voltage quality. A good way to think about that is it's like the water pressure in the city's main pipeline. It's supposed to be strong and constant. But you, the customer, you're responsible for the current you draw. And that's like deciding how far you're going to open your faucet. How you use that power can actually affect the whole system.
So, the utilities side of the bargain is basically to deliver on three key promises. They have to maintain a stable voltage level, they need to keep the frequency rock solid at 50 or 60 hertz, and they have to provide that pure, clean sine wave we keep talking about. That's their job.
All right, so if the utilities are doing their best to send us clean power, what's messing it up? Let's take a look at the real culprits that are corrupting our electricity.
The causes are all over the place. Some are external and dramatic, like a lightning strike. But here's the interesting part. A lot of these problems actually start on the customer side of things.
kicking on huge motors, or even the everyday electronics we all have, like chargers and computer power supplies. These are called nonlinear loads, and they can distort the power, for you and even for your neighbors.
So it's a pretty simple chain of events, right? First, you have a cause, say a lightning strike, or a factory starting up a giant motor. The result? That beautiful, clean sine wave gets all distorted. And that leads directly to a consequence, a specific power quality issue, with its own technical name, like a sag or a swell.
And these are the big ones. The most common problems by far are voltage sags, which are just dips in power, and swells, which are spikes. Then you've got things like transients and harmonics, which are basically just distortions of that nice wave shape, and of course, full-on outages. Each one of these is just a different kind of dirty fuel that can mess with our electronics.
And if this all sounds a little technical or abstract, I can pretty much guarantee you've actually seen it happen. You ever notice your lights flicker or dim for just a second when a big appliance like your air conditioner kicks on? Yep, that flicker, that's a voltage sag. It's a classic, everyday sign of a power quality issue happening right there in your own home.
So the next time you flip a switch, just think for a second about the incredibly complex journey that power took to get to you. The energy flowing through your walls feels constant, but it's always being rocked by these invisible fluctuations. And learning how to manage the quality of that power, well, it's one of the most important and most expensive hidden challenges of our modern world.